Hi, welcome to Ekascloud. My name is Jagadish Umapati. Today I'm going to talk about cloud computing. What is cloud computing? And also I'll be talking about different service model which is offered by the cloud computing, and also different types of the deployment models which are offered by the cloud computing. And also I'll be talking about the benefits of cloud computing. And finally, I'll be taking you through one of the sort of the data center details or a global infrastructure details of one of the cloud service provider, which is GCP, Google Cloud Platform. But today I'm going to talk about cloud computing. What is cloud computing? To talk about cloud computing, I think the discussion or the explanation has to start from the very beginning. How does the computing evolve over a number of years? In olden days, we used to talk about desktop computing. Then slowly we moved into client server model architecture kind of thing. And then we moved into cluster computing and then grid computing. Okay, first of all, we need to understand all of these computing standards or architectures before we can able to come and talk about cloud computing. So the begin with desktop computing, which was like a standalone desktop machine. All the computation which used to happen was on a desktop machine without any connection to the outside network. This used to be called as a desktop computing. This was all fine, except that it has got its own limitation where all the computation was supposed to happen on a single machine. It was not scalable, and it was not sort of more like in a distributed model where we can able to share the resources across different machines. So it has got its own limitations. So after that, the client server concept came into picture, wherein some of the load was passed on to the server, and this model worked to a certain extent. Again, here, one of the drawback here is the moment the transaction volume goes up, a single server can't be able to handle all the transactions coming towards its way. So the client server has its limitation because it is not able to scalable again. So then we moved on to the cluster computing, which is another type of an architecture where it is a group of server which used to share the load using some sort of software, more like a load balancer, which uses a specific algorithm, either it is round robin or any other specific algorithm, which used to share the load on the server. So for example, if there is a large volume of transactions coming towards a server, load balancer can able to balance the load and can able to distribute the transaction into multiple nodes. And this is what it was, a cluster computing. Cluster computing, all like a group of computers in a network, all used to work together to perform a single goal. That is cluster computing. Then we can talk about the grid computing. Grid computing is very similar to sort of cluster computing, but it differs by where the computers are located. For example, computers are all located in a heterogeneous manner in a distributed network, and with the common goal of achieving more like batch processing. Grid computing, again, it has got its own limitation, because once you scale the hardware to a specific business goal, you cannot be able to downgrade it. If tomorrow, if you realize the business needs has reduced, by the time you would have already spent the capital investment on the kind of hardware which has been procured to configure the grid computing. So which is again itself is a drawback. So considering all these different types of architecture and different types of the computing we talk about, then when we can able to move on to the cloud computing. So what is cloud computing? Cloud computing is something like the delivery of on-demand computer system resources on a pay-as-you-go basis over the internet. So what does it really means? So we can take about an example to explain about what are the current disadvantages. A lot of organizations which are currently facing. For example, we can talk about a small software firm who has got a set of network infrastructure. Either it could be located on premise, or it could be located on a remote data center. So what are the some of the challenges they are facing together as a software company, a small software firm, which can be resolved by the cloud computing. So for example, if the software company, if it has got its own data center, obviously the software company's responsibility to manage all the resources within that data center. It's more about the power to power up all the network resources within the data center, and also the cooling part of it. These are all going to add a lot of cost to it, and the warehouse storage, the security part of it, more like a physical security, as well as security to secure the infrastructure resources, the servers, the hard disks, the applications itself, the software itself. And then on top of it, it's about all the resources. To manage the entire data center, software companies needs to hire expensive resources, engineer resources, someone who works only in the networking part, someone who only works in the hardware side. So the cost will again go up. And not only it stops there, the company also responsible for the maintenance of all these hardwares and the software. For example, time and again, in this day and age, nothing is permanent. Like all the hardware, whatever you buy now, within a year that will become obsolete or become sort of very old hardware standard. So periodically the company, the challenge is they have to keep on upgrading their hardware and software. That itself is a big challenge. Obviously it involves huge cost associated with it, because all the resources will be busy in upgrading the software, applying the latest patches, then upgrading the hardware itself. Of course, and then the networking has to be done actually for all of these new resources or the existing resources whenever there is an issue. And also for high availability, these data centers needs to have a robust DR as well. So there will be cost associated with performing the DR test. And then we also can talk about scalability. So for example, existing data center infrastructure, if tomorrow the business needs of the software company increases, they obviously have to scale up. That means either they can scale horizontally by adding more servers, or they can able to do vertical scaling. That means change the existing server memory to make it more robust. Again, all these things involve cost, the kind of resource who is involved there, and the critical factor is the time, because it takes a lot of time to do all these things. So now looking at this, and also of course there is a compliance and regulatory aspects as well in terms of the both hardware and software, especially in the major financial organization who spends a lot of money to ensure their all the network infrastructure is up to the standard and using the latest technologies. So there also again the companies and the organizations spend huge amount of money to be compliant and to be on the regulatory side. So what are the things? I mean, these are all the problems what anyone like either an individual or an organization is currently facing. Anyone who has got a software system to manage, anyone who has got a network infrastructure needs to be managed. So now we can talk about cloud computing, which I told you about. It is a cloud computing is the delivery of on-demand computer system resources on a pay-as-you-go basis over the internet. So that means all the problems what I have just explained can be resolved using the cloud computing. So what do you mean by that? For example, tomorrow, scalability, right? We talked about scalability, the kind of issues we are facing. So on-demand scalability, we can able to perform using cloud computing with a couple of clicks. We can able to configure auto scalability, wherein tomorrow if the business needs increase, the cloud computing will automatically offers upscaling of the servers required. So there is no manual intervention involved. All it needs is a configuration and a couple of clicks. Similarly, there is no manual in terms of the resource cost. It will be substantially less. And also cloud computing provides robust security, and also it provides the robust DR infrastructure for high availability. And also cloud computing, the companies don't need to bother about worrying about the power aspect or the cooling aspect or the warehouse storage, the security, or in fact the maintenance, because all the maintenance of the both the hardware and software will be provided by the cloud computing on demand on a pay-as-you-go basis. What does it mean? What it means is, when you have a particular system, you can able to use the resources what you need, rather than spending a lot of money on the capital investment. You will be spending what you will be using across the internet. So if your demands automatically reduces, then your entire infrastructure can be reduced. That means you'll be paying less. So obviously, if the demand, business demand increases, or the transaction volume suddenly increases, then automatically it can scale up. So this is the advantage of having a pay-as-you-go on the internet, whatever the cloud computing provides in terms of the services. So, and also looking at this cloud computing, currently in the market, who are the major players? So currently we have three major vendors who are providing cloud computing services. They are AWS, which is from the Amazon, Azure, which is from the Microsoft, and then Google Cloud Platform. This is from the Google company. Okay, so now we spoke about what is cloud computing, what are the benefits of it, how we can able to move from traditional computing like cluster and grid computing onto the cloud computing. Now we are going to talk about the different types of deployment models, what the cloud can offer. So there are three different types of deployment model what any cloud can able to offer. That is the private, hybrid, and public. So what does it mean by that? In the previous example, to explain about cloud computing, I used an example of on-premise network infrastructure or a data center. So in the case of a data center, normally it will be accessed only by the organization or the employees of that organization, and it will be restricted to only for those people or the organization. Whereas public cloud is a computing model in which a third-party provider makes the compute resources available to the general public over the internet. So that means the public cloud is accessible to all, whether it is an individual or with an organization. As long as they have the access to the internet, they should be able to access the public cloud. So again, as I explained, there are top vendors who provides the public cloud, which is the AWS, Microsoft Azure, and Google Cloud Platform. So the public cloud is, again, the network infrastructure is multi-tenant architecture and pay-as-you-go pricing model. That means which is the major advantage for any organization, that you pay for what you use. Okay, and now next, moving on to the private one. What is private cloud? So the private cloud is nothing but a data center which is privately allocated to an individual company or a individual resource or individual end user. So what does it mean by a private cloud? Private cloud is nothing but the cloud resources will be only available to an either organization or to the employee of the organization. Only those people can able to access resources within the private cloud. A cloud computing model in which an enterprise uses proprietary architecture and runs cloud server within its own data center. What are the top vendors within the private cloud? We got HPE, VMware, Dell EMC, IBM, Red Hat, so on. So we spoke about public and private, but majority of the organization, they wanted to use a cloud deployment model called hybrid. This is because the critical aspect of hybrid cloud model is For all organizations, the most critical factor for them is the data. They are happy to probably use public or private cloud, where they can able to go and utilize the computing resources already available on the cloud model or the cloud computing or the cloud platform. But many of the organizations, they are not willing to share their data across the cloud, which is because there are a lot of concerns regarding the security aspect of it, the data leakage, the data loss, all those aspects sort of like many organizations not comfortable sharing their data. So what can they be able to do it? So using the hybrid cloud model, they can have a mixture of private and public cloud. That means they can still have some of the network infrastructures either on premise or within a data center that is within the private cloud. And they can still use some of the network infrastructure from the public cloud for scalability purpose, so that the data will be located in the private cloud, but most of the other networking infrastructure will be available in the public. So the huge advantage with this is either a customer or a company, they will have complete control over the data. Okay, so the cloud computing model that includes mix of on-premises, private cloud, and third-party public cloud services with orchestration between the two platforms. So what are the top vendors which provides both public and private? It is called the hybrid one. Combination of both public and private cloud providers. We already discussed about public and private cloud providers already in the previous slides. So now we are going to move on to the different types of service models. What do you mean by service model? So we spoke about what is cloud computing. We spoke about the different deployment models what cloud offers, but there are three individual basic service models which any cloud infrastructure or cloud service provider will provide. They are called IaaS, which is infrastructure as a service, and then the second one is platform as a service, and then third one is software as a service. So we just have to look at them in a chronological order, purely because infrastructure as a service, to understand all of these services, probably we still need to look at the on-premise environment. So if you look at any current on-premise environment or a existing data center, we talk about a networking aspect, networking components, the storage components, the servers, and then the virtualization part. Of course, then the operating system, middleware, runtime, data, and applications. So all of these things in an on-premise environment or in a data center, there is a lot of manual intervention involved to configure all these resources, to create a networking. So there is a lot of, you need an expensive network engineer who has to go there, connect all of these different components to make a proper running networking. Okay, the storage component, the servers, the virtualization, all of these things are independent, and there is a lot of manual intervention involved. So what is infrastructure as a service when compared to the on-premise environment? So in infrastructure as a service is a service model which offers networking, storage components, servers, and the virtualization part will be provided over the internet, either to an end user or to the organization. That is called infrastructure as a service. So then the organization only needs to worry about managing the middleware and also configuring the software and installing the runtime library, and then of course the data and the applications. So that will be the responsibility of the organization who uses infrastructure as a service. So now we move on from infrastructure as a service to the platform as a service. So what does platform as a service provides? To understand this, you have to think like, again, in an example of a software company, for developers, if you want to hire developers who want to be more productive, they needed a development environment. Okay, so the development environments, they need the virtual machine, they need the machine to be connected to a network, and then obviously you want to have some sort of storage, either in terms of database or whatever form. And then obviously you need to have server, dev server, UAT servers, whatever we can think of. On top of it, we also, for example, when a developer wants to do any development, you wanted to use some of the middleware, some of the API, and then some of the runtime libraries as well. So all of these things will be provided by the cloud platform as platform as a service. And this is what is called platform as a service. So all the organization or the end user has to do is configuring the data and the applications part. So rest of the infrastructure will be provided by platform as a service. Okay, so now we move on to the software as a service. This is the last one and the most beneficial to the customer. Obviously, it is more expensive. This is the one where this service model offers applications over the internet for end users to use on a cloud platform. So that means the organization or an end user don't have to worry about any of the infrastructure and also about the application. So what are the examples of software as a service? There are many examples in day-to-day world right now. You can talk about Gmail, you can talk about any of the services offered by the Google, for example, the Google storage that is also provided as software as a service. So these are all the things where the end user or an organization don't have to do anything. So they can able to just go there and use software as a service, where they can able to have an application ready-made available, where that application is already deployed on the cloud computing infrastructure. So these are all obviously the three different types of the service models. Depending on individual needs of a customer, either end user or an organization, they can able to go and use any one of these services. Now we move on to the benefits of some of the cloud computing. When I explained about the cloud computing, what is cloud computing? So cloud computing provides computing infrastructures on an internet over based on demand on a pay-as-you-go basis. So what is the advantage of doing this? So for many organizations, the major benefit is the cost saving. As we saw, there are most of the regular issues related to having a cloud, the data center or having a on-premise environment there are major hurdles regarding the power one, the cooling part of it, and warehouse storage, the security aspect of it, and human resources required to manage all the network infrastructures, and then of course the maintenance part of it, of both hardware and software, and obviously the networking components as well. So all of these things we can able to save cost with the cloud computing, because it provides all of this networking infrastructure as a service. So again, we saw both as an infrastructure as a service, then platform as a service, or software as a service. Again, based on the individual organization need, one can go for choose any one of these services, and they can make a massive benefit out of the cloud computing. And also it offers unlimited storage. For example, if you go with a data center on-premise environment, always you have to order extra hardwares. Sometimes it is available, sometimes it might take more time. Whereas in the cloud computing, the storage will be available on a more configuration fashion as a service output, where you can able to go with a couple of clicks, you can able to order a storage, which always provides unlimited storage. So an end user organization don't need to worry about the shortage of storage here. And then of course it provides automatic software update. So again, organization or end user don't need to worry about the software updates and maintenance of the existing network infrastructure. This will be automatically provided by the cloud computing. And then the performance. Cloud computing provides the latest technology stack, whether it is in terms of software or the hardware. So it is the responsibility of the cloud service provider to ensure both software and hardware are of the latest standard and latest version. So this obviously gives a better performance. Scalability. So again, cloud computing offers automatic scaling, whether depending on an individual need or an organization need. If someone wants to upscale it, automatically cloud computing can able to add more resources to support the additional transactions, or it can scale down if there is not much transactions going on, And if the business needs are less, so it can automatically scale down. So it can use less resources and it can save money to the organization. And also the 24/7 availability using the robust DR infrastructures within the cloud. And of course, the reliability part as well. These are all some of the benefits offered by the cloud computing. Okay, so now move on to, this is the last slide where I'm going to talk about the existing Google Cloud locations and network. So to form a cloud network, obviously there are different nodes are involved. If you talk about a networking from a very high level perspective, there are regions involved because this is truly global in nature, where Google has made the Google cloud computing services available in major regions across the world. So there are 27 regions right now across the world where Google are providing its services. And then in each of the region, there can be multiple zones. So right now, again, across the world, it is providing 82 zones. And then there are network edge locations. And then it's up to 200 plus countries and territories it is providing its services. And also when you talk about Google services, Google platform or the Google Cloud Platform services, there are many services which is provided restricted to individual region. Because we talked about only the 3 services, but Google provides many more services. So some of these services may not be available in every single region. But the one which I'm specifying on the slide is the global products. These products are available to every single region, every single zones, and then across these 200 countries and territories. They are like, for example, networking, Cloud CN, Cloud Interconnect, Cloud DNS, etc. And also data analytics. It provides Data Studio and Data Lab. Like this, it also provides some global products called Cloud Source Repositories, Cloud Build. In terms of the operations for monitoring and logging, it provides cloud logging, monitoring, trace, profiler, debugging, and error reporting. And also in terms of the security, the global products which Google offers is Cloud Data Loss Prevention, Security Command Center, Identity and Access Management. And this is the final slide, which just explains about the entire Google Cloud global infrastructure. So here you can able to see the kind of networking cable Google has managed to run across the world. So the cable, for example, you can see here the green ones are all submarine ones, where some of the cable they have run under the sea to connect across different geographical equations across the globe. So this is a very robust kind of network what Google is providing. Similarly, of course, we have Azure, and also we got AWS. They also provide a similar infrastructure, which is truly global in nature. If you look at the market share, currently AWS is leading at the moment. And then second is the Microsoft platform, which is the Azure one. And the upcoming Google infrastructure, cloud infrastructure, is a Google one, which I'm able to see it here. So with the last presentation, I'm going to stop here. And thank you all for listening. Thank you.